Yes, children. Let me talk about some of the very important concept of class 9 ICSE, that is indices. The topic what you have chosen today is indices. First of all, you must know what you mean by indices. See, whenever I am writing a number 2 to the power of 3, so here I can write this one as 2 into 2 into 2 3 times, because 3 is over here. So this is called as a product form. This is called as a product form, and this is called as the index form. That is called as a index form. Any number you can take. I'll take one more number. For example, 3 to the power of 4 if I write. Okay, so it can be written as 3 into 3 into 3 into 3. So here I can say this is the product form. This is the product form, and here this one is called as the index form. This is index form. So what is the answer for 2 into 2 into 2? It is 2 multiplied by itself 3 times. 8 is the answer. 3 multiplied by itself 4 times. So we get 27 into 3, that is 81 as the answer. Clear, children? So over here, whenever an index is written in the product form, you must know the index should be positive number. This should be positive number. So over here I have written like 2 to the power of 3. So here this 3 is called as a index, or it's also called as a exponent, or it's also called as a power. It's also called as power. Here 2 is called as a base. 2 is called as a base. Clear, children? So it happens when I'm talking about the numbers. It may happen with the algebraic terms also. For example, x square. You know that how x square is obtained. X square is obtained by multiplying x twice by itself, so it is x square. So how I am telling the answer over here 8, right? Here 81. So here I cannot tell any answer because the value of x is not fixed. Clear, children? So I'm just keeping it as x square. So over here this is the index form and this is the product form. Clear? As I told you, the index form of a number can be written in the product form only when you have the positive power. Suppose if they have the negative power. Okay. Example, 2 to the power of minus 3 is there. It cannot be written as a minus 2 into minus 2 into minus 2. That is wrong way of writing. So since the index is negative over here, I have to make it positive. So how can I make it positive? You must know that 2 to the power of minus 3 can be written as 2 to the power of minus 3 by 1. So whenever a number is taken from the denominator to numerator or numerator to denominator, sign of the index will change. Sign of the power will change. Right. So 2 to the power of minus 3 can be written as a 1 by 2 to the power of 3. So I have got the power as positive now. Now I can write this one in the product form like a 2 into 2 into 2. So that is equal to 1 by 8 is the answer. You must know, children, whenever I'm talking about the speed unit, SI unit of the speed, we say that meter per second. You must have written this one. Meter per second, that is meter by second. Sometimes I write this one as meter second to the power of minus 1. Why it is so? Because here to the power of 1 is there. When it is taken to the numerator, s to the power of minus 1 it becomes. Okay. So the unit of acceleration, meter per second square I write. When it is taken to the numerator, I can write it as meter second to the power of minus 2. See here, the index is taken, the negative number is taken, the positive number is taken from the denominator to the numerator, so it is written as minus 2. Clear, children? Right. So whenever positive index is taken from denominator to numerator, it becomes negative. Negative is taken from denominator to numerator, it becomes positive. Clear, children? Okay. Suppose I'll just give you one more example. Suppose if I have 2 to the power of minus 3 by 3 to the power of minus 2. So what is the value of this number? So I cannot directly write the value of this number until and unless I convert it as a positive power. So I write this one as 3 to the power of plus 2 because I am taking it from the denominator to the numerator. Then I am taking this from the numerator to the denominator. So I can write this one as 2 to the power of 3. So here I can write it as 3 into 3 by 2 into 2 into 2. So this becomes a 9 by 8. Clear, children? 3 into 3 is 9. 2 into 2 into 2 is 8. So 9 by 8 is the right answer. Clear, children? Suppose if I have one more number, I'll just take one example over here. 2 to the power of minus 3 into 5 to the power of 2 by 3 to the power of minus 3 if I have. Right. So what is the value of this? Okay. Find the value of. Find the value of. Okay. This one. So here I cannot directly find out the value of this until and unless I convert this one as the positive power. So what I do over here, I write this 3 to the power of minus 3. I'll take it to the numerator so that negative power will convert to positive power. So I can write this one as 3 to the power of plus 3. Then see, if you observe carefully, 5 to the power of 2 is there. It is already positive. So I don't try to take it down. I'll keep it as it is in the numerator. So 5 to the power of 2 it becomes. So later 2 to the power of minus 2 is there. So I want the power to be positive. So I will take it to the denominator. So 2 to the power of 2 it happens to be. Clear, children? So later I can write this one as 3 to the power of 3 is 27 and 5 to the power of 2 is 25 divided by 4 I can write. Clear, children? So later I can multiply this one, right? So 25 into 27, that is 175, and 17 over here, 25 2s are 50, 50 plus 17 is 67. So divided by 4. So this is going to be the answer. Is it clear, children? Okay, so this is what happens whenever you're dealing with the exponents. That is nothing but indices only, but when you're taking the numbers, right? Suppose I'll take the second example. Look at the second example over here. Suppose if I'm having 3 a to the power of minus 3, b to the power of minus 6, c to the power of 7 by x to the power of 2, y to the power of minus 5. Okay, the question is express, okay, all the terms with the positive powers, with the positive powers. Okay, so if this is the question, express them with the positive powers. So now what can I write? See, a to the power of minus 3 is there, so it is negative power in the numerator, so that to be brought down. Whenever I'm taking a to the power of minus 3 down, it becomes a to the power of plus 3, b to the power of minus 6 there, and it is in the numerator, so I have to take it down, so it becomes b to the power of plus 6, and c to the power of 6 is 7 is there, it is already having positive power and it is there in the numerator. I don't touch that one, I just keep that one as it is. So when it comes to denominator, I have x to the power of 2 over here, and the sign of the power of x is to itself, I mean plus to itself, so I'm going to keep it as plus 2 in the denominator only. But when it comes to y to the power of minus 5, since the power is negative, I'll take it to the numerator, it becomes y to the power of 5, y to the power of 5. This is how I can convert the negative power as the positive power, and positive power, okay, as the negative power, when I take them from the numerator to the denominator, denominator to the numerator. Clear, children? So as I told you, once again I just repeat, 2 to the power of 4, if I am writing, this 2 is called as a power, or it's also called as a index, or it's also called as a exponent. It's also called as exponent, and this 2 is called as a base. This 2 is called as base. Is it clear, children, all of you? Yes. So now let's move to the next part of the concept, that is laws of indices. Okay, we are going to learn about laws of indices. What are the different laws of indices? The first law is called as a product law. The first law is called as a product law. Let us learn what is product law, what it's going to tell about. Clear, children? So now product law says that a to the power of m into a to the power of n. Then I can write this one as a to the power of m plus n. Right? So if the bases are equal, then their powers to be added. Then their powers to be added. I'll give an example over here. So example, 2 to the power of 5 into 2 to the power of 6 if I have. So this can be written as 2 to the power of 5 plus 6. So that is nothing but 2 to the power of 11 is the answer. That is about the product law. Next one is the quotient law. Quotient law. So what quotient law tells about? In the quotient law, I divide the quotient law into two parts. Okay, first one, look at this. Here I can say a to the power of m by a to the power of n. Then it is equal to a to the power of m minus n if and only if m is greater than n. If and only if m is greater than 1. So I'll give an example over here. Suppose if I have 3 to the power of 7 by 3 to the power of, say for example, 5. So here power of the numerator is greater than the power of the denominator. You must know, children, if anybody require money, the person with the less money will always go to a person with the more money. So here lesser power should go to a bigger power. Clear, children? So I can write this one as 3 to the power of 7 minus 5. So that becomes 3 to the power of 2. Clear, children? Okay, so here another part of the quotient law, I can write this one as a to the power of m by a to the power of n is there. Then this can also be written as a to the power of n minus m if n is greater than m. See here, if n is greater than m, in the sense what children, here I have the power of the numerator is lesser than the power of the denominator. I'll give you an example over here. Say for example 3 to the power of 8 by 3 to the power of 12 if I have. So here in this example, if you observe carefully, the power of the denominator is greater. In such cases, what can I write? 1 by 3 to the power of 12 minus 8, that is equal to 1 by 3 to the power of 4 is the answer. So here in the second cases, the power of the denominator is greater, power of the numerator is smaller. So whenever I'm talking about the product law and the quotient law, keep in mind children, very important that they should have the like basis. Okay, so the exponents should have the like basis, then only the product law and the quotient law can be applied. If they don't have the like basis, if the given exponents don't have the like basis, we cannot apply any of the product law or quotient law. Clear children? Okay, so now third law we are going to study. That one is nothing but a power law. Okay, so in the case of power law, what is going to happen is a to the power of m to the power of n. Suppose if it is a to the power of m to the power of n, then it is going to be a to the power of m into n. See here I have only one base, okay, and it has got the power. So I'll give you an example over here. Look at this very carefully. If I have 3 to the power of 2 to the power of 5, 3 to the power of 2 to the power of 5. So then I can write this one as 3 to the power of 2 into 5, that is equal to 3 to the power of 10. This is nothing but the power law. If you carefully observe children, this quotient law, product law, they can be interchanged with the rules whatever I told you in the previous case. Whenever the denominator is taken to the numerator or numerator is taken to the denominator, sign of the power changes. So this can also be interchanged. If you observe carefully, how can they be interchanged? Look at this. So suppose if I have 2 to the power of 4 by 2 to the power of 14, I'll take example 2 to the power of 3 if I have. See what I told, whenever the power of the numerator is greater, I need to take the denominator to the numerator and apply the quotient law. 2 to the power of 14 minus 3, that becomes 2 to the power of 11. So other rule, if I come across the other rule, I told that 2 to the power of 14 by 2 to the power of 3 is there. See, if a denominator is taken to the numerator, sign of the exponent will change, sign of the power will change. So here 2 to the power of 14 I can write into 2 to the power of minus 3 I can write. Clear children? Because I have taken the denominator to the numerator, sign of the power will be reversed. If it is plus, it becomes minus. If it is minus, it becomes a plus, right? So now if I apply the product law, it is going to be like 2 to the power of 14 minus 3, that is equal to 2 to the power of 11. That is equal to 2 to the power of 11. Is that clear children? Okay, along with this, you need to remember some of the very important note over here. What are the different note what you need to remember? First one is, whenever I am multiplying two numbers and raising them to certain power, example a into b to the power of n, then it is same as a to the power of n into b to the power of n. A into b to the power of n is equal to a to the power of n into b to the power of n. Clear children? But you should keep in mind that a plus b to the power of n is not equal to a to the power of n plus b to the power of n. Clear children? So the second case, when I divide one number by another number and raise them to the power of certain number, then it is a to the power of n over here by b to the power of n. Okay, so the power belongs to both the numbers only if they are multiplied or only if they are divided. Clear, children? So next one is whenever any number raised to the power of 0. Whenever any number raised to the power of 0, the answer is always 1. Why it is 1? Because say for example, a to the power of 2 I have, by a to the power of 2 if I have. Okay, so it is same as a to the power of 2 minus 2. A to the power of 2 minus 2, that is equal to a to the power of 0. So why it is 1? See, a square and a square can be cancelled. When you cancel a square and a square, what I get, children? We get it as 1. That's how any number to the power of 0 is 1. Are you all getting it, children? Okay, now next one is the fourth one. Whenever I'm talking about certain number to the power of some fractions, okay, say for example a to the power of half if I'm taking, it is same as look at this, a inside the square root sign and here order is 2. Say for example, if I give you one more example, a to the power of if I have 1 by 3, then I can write this one as a in the root sign, but it is cube root over here since the denominator is 3. Suppose if I have a to the power of 2 by 3, then this can be written using the reverse power law, like a square to the power of 1 by 3. So if the power is 1 by 3, I can write this one as cube root of a square. Cube root of a square. Are you all getting it, children? I hope so it is clear. Okay, so whenever I'm expressing roots over here, always you need to remember the denominator, okay, becomes the order of the root. Are you all getting it? Okay, yes. So now fifth one very important thing I will tell you. Whenever a negative number is raised to the power of even number, negative number is raised to the power of even number, answer is always positive. Okay, or whenever a negative number is raised to the power of a odd number, so answer is always negative. Okay, so negative number to the power raised to the power of even number, answer is positive, and negative number the power of odd number, then we get the negative number. Clear, children? Okay, so now next one is very important thing. See, here we learned about the 5 important note. Now we are going to learn the 6th one. Look at this very carefully, children. So a to the power of m is equal to a to the power of n. So then I can write m is equal to n. In the sense what? In the sense what? If bases are same, if bases are same, then equate the powers. Then equate the powers. Okay, I'll give you an example for this. Look at this, children. I can give you an example. Suppose if I'm asking you, look at this. Find the value of x. Find the value of x. Then example I can give like 2 to the power of 3 is equal to x to the power of 3. So here, look at this. Since the powers are same, okay, equate the bases. Okay, so now I can write 2 is equal to what, children? X. Why? Because since I'm telling if the bases are same, equate the powers. Similarly, I can say if powers are same, then equate the bases. Equate the bases. Clear, children? Okay, the powers are same, equate the bases. If bases are same, equate the powers. So look at this. 2 to the power of x is equal to 2 to the power of 4 if I have. In this case, since the bases are equal, I can write x is equal to 4. Why? I can write over here, if bases are equal, then equate the powers. Equate the powers. Clear, children? Okay, here in these cases, the powers are equal. I have equated the bases. In these cases, the bases are equal. That's why I have equated the powers. Is that clear, children, all of you? I think so you are getting it. Clear, children. So, but one thing you must know that I don't ask you like mention the laws of indices in the exam. I, in the sense, your teachers or board never ask you, right, what are the laws of indices? Mention them. No. Okay, always you must know that the questions based upon the applications of these laws are asked. Clear? So you must know how to develop the skill of application. Okay, application, right? So in the ICSE or CBSE, application level questions are asked. You must know the skill of tackling the application based questions. Clear, children? Okay, so now let me take some of the examples over here. Right, I have selected some of the examples over here. Let us learn how to solve them to arrive at the answer by applying the laws of indices if necessary. Okay, so now the first one is, so whenever I'm having the basis as certain numbers, first and foremost important thing what you need to learn is we have to express the base as the prime number. So prime number. So what do you mean by prime number? You must know. Prime number is the number having factors, having factors as one and itself. One and itself means what? They should not appear in any of the tables other than one and itself. So basis should be expressed as the prime number. Basis should be prime numbers. Clear? So now I will write 3 to the power of 3 as it is. So now here I have 243. So 243 I should express it as some prime number to the power of minus 2 by 3. How can I get to know what is the prime number? See, I'll do the prime factorization. 243, I will do the prime factorization. So 3, 3 8s are, 3 1s are, then 3, 3 2s are, 6 here, then 3 7s are, then 3, 3 9s are over here, 3, 3 3s are, then 3 1s are. So 243 means what? 1, 2, 3, 4, 5. So 3 to the power of 5, 243, I have expressed it as 3 to the power of 5, and I am going to retain minus 2 by 3 power as it is. Into 9 is there. 9 can be written as 3 to the power of 2 to the power of minus 1 by 3. Power I have written as it is. So I have expressed all the bases as a positive, all the bases as a prime numbers. So now what can I do? 3 to the power of 3 I will write. So here I will apply the power law. So 3 to the power of 5 into minus 2 by 3 into 3 to the power of 2 into minus 1 by 3. You know what is power law, children? A to the power of m to the power of n if you have, then I can write this one as a to the power of m into n. Clear, children? So later what can I do? Here 3 to the power of 3 I will write as it is. This becomes 3 to the power of, here 5 into minus 2 is minus 10 by 3 into 3 to the power of minus 2 by 3. So later I can write 3 as it is. See, I can apply the product law over here. So why I can apply the product law? Because I have the like basis. So 3 to the power of 3, then plus of minus 10 by 3 plus of minus 2 by 3. So means what? A to the power of m into a to the power of n is there. I can write this one as a to the power of m plus n. Okay, so that's why I have added them. So I can write this one as 3 to the power of 3 minus 10 by 3 minus 2 by 3. Here nothing is there means what? 3 to the power of 1 it is. So I'll take the LCM over here. See, look at this. 3 by 1 minus 10 by 3 minus 2 by 3. If I take the LCM is going to be 3. Then here 1 is there to be multiplied with 3, to be multiplied with 3. 3 into 3 is 9, and already 3 is there in the denominator, minus 10 and minus 2. Clear, children? So I can write this one as 3 to the power of, look at this, what I'm going to get over here. This is minus 3 by 3, because minus 12 plus 9 minus 3 by 3, that is equal to minus 1. 3 to the power of minus 1 I get over here. So I told you that I need to always express it as a positive power. I can write this one as 1 by 3. Clear, children? I hope so this is clear, right? So what is the final answer here? It is 1 by 3. 1 by 3 is the final answer. Now let me take the other example over here. Okay, so second example was quite simple in this exercise, so I have taken the third example directly. So now over here 27 is there. You must know 27 is not a prime number. Okay, so I need to prime factorize 27. So what I do, I will write 3 to the power of 3 by, again 125 can be written as 5 to the power of 3 to the power of 2 by 3 into 9 can be written as 3 to the power of 2 by 5 can be written as 5 to the power of 2 to the power of minus 3 by 2. Right. So now I told you that a to the power of n by b to the power of n is there. I can write this one as a by b to the power of n. So here, since same power is there for the numerator and denominator, I can write this one as 3 by 5 to the power of 3 to the power of 2 by 3. Clear, children? Okay, later 3 by 5 to the power of 2 and to the power of minus 3 by 2. Again, I will apply the power law. When I apply the power law, this becomes 3 by 5 to the power of 3 into 2 by 3 into 3 by 5 to the power of 2 into minus 3 by 2. So over here, this 3 and this 3 will get cancelled. This 2 and this 2 will get cancelled. So now here 3 by 5 is there. Here also 3 by 5 is there. This becomes 3 by 5 to the power of 2 into 3 by 5 to the power of minus 3. Clear, children? So when I apply the product law, because like bases are there, I can aram se apply the product law. When I apply the product law, this becomes 3 by 5 to the power of 2 minus 3, that is nothing but 3 by 5 to the power of minus 1. I told you I should not keep the final answer with the negative power. So what I do, I will convert them as a positive power. So when should how can I convert them as a positive power? So reciprocate them. So means what? 5 goes to the numerator and 3 comes to the denominator. So the final answer is going to be 5 by 3. Clear, children? So this is how I can solve the question. Now let me take the other question over here. Look at the question over here, children. Be very, very careful. Okay. Now question number 5. I have selected only few questions which based upon the concept of laws of exponents. So now look at this. 16 by 81 is there. 16 can be written as, see how do you get the hint, children? What should I express the power as? See, if you observe the power carefully over here, power is 4 over here. So I need to express this 16 as some prime number to the power of 4 and 81 as some prime number to the power of 4. Similarly, 49 as some prime number to the power of 2 because denominator 2 is here, and this 9 should also be expressed as some prime number to the power of 2. Same thing over here, same thing over here. So let us observe how actually I'm going to work on it. Clear? So now I can write 16 as, see, 16 is 2 to the power of 4 and 81 is 3 to the power of 4. So I will write this one minus 3 by 4 as it is. So how do I get to know 16 is 2 to the power of 4? You do the prime factorization. Look at this. 2, because it is even number, obviously it is divisible by 2. Hi, Srijan Sadashiv. Hi, Rohit. Okay, you can please respond, children. Rohit, Srijan, right? If you are following, please let me know. If you are having any difficulty, please let me know. Okay, 2 8s, then 2 4s, and 2 2s. Okay, see, look at this again, 2 1s. So 16 can be written as 2 to the power of 4. 2 to the power of 4. Clear, children? So that's how I have written 2 to the power of 4 here. Same thing with 81. So into 7 to the power of 2 by 3 to the power of 2 to the power of 3 by 2. Then I have division sign over here. 343 can be written as 7 to the power of 3, and over here 216 is there. 216 can be written as a 6. See, 216, when I'm writing this one, 2108, okay, 254, then 227, then 3 9s, 3 3s, then 3 1s. So 216 means what, children? It is 2 to the power of 3 and 3 to the power of 3. So I can write this one as a, when I apply this, 2 into 3 to the power of 3 I can write. So 2 into 3 to the power of 3 whole to the power of 2 by 3, because 2 by 3 is already given in the question. Srijan, Rohit, I hope so you guys are following whatever I'm discussing on the screen over here. Please let me know if you are having any difficulty. Clear, children? So now I will apply the next rule, that is I'll take it as a common power. So 2 by 3 to the power of 4. Okay, then if I apply the power law, this becomes minus 3 by 4 into 7 by 3 to the power of 2 into 3 by 2. So here I have division. Okay, so I don't convert directly to the multiplication. First I will convert it to the division. I just keep division as it is. Later I will convert it as a multiplication. So what I do here is division sign, I'll keep it as it is. 7 by 2 into 3 to the power of 3 into 2 by 3 I will write. Clear, children? So now this 4 will get cancelled. Then later over here this 2 will get cancelled. This 3 will get cancelled. So I'm left with what? 2 by 3 to the power of minus 3 into 7 by 3 to the power of 3 divided by 7 to the power of 2 by, since 2 is there, I told you that a into b to the power of n is there. I can write this one as a to the power of n into b to the power of n. So this power to be taken for 2 as well as 3. So 2 to the power of 2 into 3 to the power of 2. Clear, children? I hope so it is clear how actually I got this expression. Clear? So now what I do is, please pay attention and look at the screen very carefully. So now, since it is a negative power, I will make it as positive. So I'll write this one as 3 to the power of 3 by 2 to the power of 3. Right? So into 7 to the power of 3 by 3 to the power of 3. So division sign, I'll make it as multiplication sign. Division sign, I'll make it as multiplication sign. After that, I'll take the denominator to the numerator. So 2 to the power of 2 into 3 to the power of 2 by 7 to the power of 2. Clear, children? Okay, so now where are the like bases? Here 3 is there, 3 is there. So I can write them as 3 to the power of 3 minus 3 plus 2, because 3 is over here, 3 is over here, and 1 3 is over here. So I have 2 here, but 2 to the power of 3, this is smaller, and this is 2 to the power of 3 is greater than 2 to the power of 2. I can write this one as 2 to the power of 3 minus 2. I have considered 3 as well as 2. Now 7 if I consider, see, 7 to the power of 3 is greater. Well, you have 7 to the power of 2 in the denominator. So 7 to the power of 3 minus 2. So what I get answer here, I get it as 3 to the power of 2, because plus 3 minus 3 will get cancelled, into 7, I get it as 2. So 3 to the power of 2 is 9. 9 into 7 is 63 by 2. The answer is What is the answer, children? 31.5 or 31 1 by 2 you can keep. This is our final answer. Is that clear, children? I hope so it is clear to you. Understood? Okay. So now whatever we are going to do is the next question. Pay attention. So over here I have, pay attention, children, 8 into x cube. So what can I wrote? So 8, I can write this one as 8 is equal to 2 to the power of 3 into x cube divided by 125 can be written as 5 to the power of 3 into y cube to the power of 2 by 3 to the power of 2 by 3. So later I can write this one as 2x by 5y to the power of 3 whole to the power of 2 by 3. Clear, children? Okay, because since the powers are same over there, I can directly take it. Clear? So now this becomes 2x by 5y to the power of 3 into 2 by 3. So I can apply the power law. So when I apply the power law, 3 and 3 get cancelled. I'll be left with what? 2x by 5y to the power of 2. So that means what, children? 2 to the power of 2 into x to the power of 2 by 5 to the power of 2 into y to the power of 2. So that becomes 4x square by 25y square. 4x square by 25y square is the final answer. Clear, children? I hope so this is clear. So now let's move to the next question. The next question is, pay attention, children. So here I have 5 to the power of n plus 3. I'll keep this one as 5 to the power of n plus 3 as it is, minus of 6 into 5 to the power of n plus 1 by, so here 9 into 5 to the power of n is there, minus 5 to the power of n into 4 I will write. In place of 2 to the power of 2, I'll just write it as 4. So now I can apply the reverse product law. What is reverse product law? See, a to the power of m into a to the power of n is there. I can write this one as a to the power of m plus n. Suppose if I am given with a to the power of m plus a to the power of n, I can write this one as a to the power of n into a to the power of n. So here 5 to the power of n plus 3 is there. I can write this one as 5 to the power of n into 5 to the power of 3 minus of 6 into 5 to the power of n into 5 to the power of 1. Okay, by again I retain the denominator as it is, minus 5 to the power of n into 4. So what I do the factorization. So 5 to the power of n is taken common. Okay, so 5 to the power of n is taken common. If you want, you can take out 5 also, or if you don't want, you just keep this as it is, 5 to the power of 3 inside, then 6 into 5 will remain inside. By, again in the denominator, 5 to the power of n is taken out, 9 minus 4 will remain inside. So 5 to the power of n, 5 to the power of n will get cancelled. So I am left with what here? I am left with 5 to the power of 3, that is 125, minus of 6 into 5 is 30, divided by 5, that is 9 minus 4. So 125 minus 30, what do you get, children? I get it as 95. Okay, by 5. So the answer is going to be 19. That is nothing but the final answer. 95 divided by 5, 19 is going to be the answer. Clear, children? Okay, let's move to the next one now. Pay attention over here. So here I have taken a question from third main, right? So 1 by 4, square root of 1 by 4. So square root of 1 is 1. Okay, square root of 4 is 2. Directly I can write. So it is exactly, see, it is like this, children. So 1 by 4 to the power of half. So 1 by 2 to the power of 2 to the power of half. So 1 by 2 to the power of 2 into 1 by 2. So that is how I get it as 1 by 2 directly. I have written it over here. So plus of here 0.01. 0.01 in the sense what it is? 1 by 100 to the power of minus half, minus of 3 to the power of 3 to the power of 2 by 3 to the power of 2 by 3. Srijan, are you getting it? Okay, Rohit. right? I hope so you guys are watching. Please comment if you have anything to say. Clear? So now it is 1 by 2 plus of, here this can be written as, you can just write it as a 10 to the power of 2. When it is negative power, I want to make it as positive power, so 100 I will take it up, then to the power of half I will write minus 3 to the power of 3 into 2 by 3. So 1 by 2 plus of 10 to the power of 2 into 1 by 2, because height 100 can be written as 10 square. Clear, children? Minus of this 3 will get cancelled, then I'll be left with 3 to the power of 2. Okay, so now I can write this one as 1 by 2 plus, look at this again, this 2 will get cancelled, I'll be left with 10 minus of 9, because 3 to the power of 2 is 9. Clear? So I'll be left with what, children? Half plus 1, so that is nothing but 3 by 2, that is nothing but 1 by 2 is the final answer. I hope so you are getting it, children. Yes or no? Okay, so now let us proceed with the next question. Let us proceed with the next question. Observe the question carefully. So over here, I have taken a question where you need to simplify or evaluate. Okay, the question is to simplify or evaluate. So now what I do, I start removing the bracket from the interior, right? So this minus 1 as it is, flower bracket as it is, 1 minus. See, if you observe, minus 1, 1 minus n to the power of minus n. So I can write this one as 1 by 1 minus n. So I'll close the flower bracket, minus 1, flower bracket, square bracket, minus 1. Why I have written it in the denominator? Because it has got the negative power. So later what I do, 1 minus flower bracket, here if I take the LCM, it becomes 1 minus n. Here nothing is there, means 1 is there. I can write this one as 1 minus n minus 1. Then again close the flower bracket, minus 1, square bracket, minus 1. In the next step, I'll take the square bracket, 1 minus of, I keep the flower bracket as it is. This plus 1 minus 1 will get cancelled. I'll be left with minus n, 1 minus n. Then I'll write this flower bracket as it is, to the power of minus 1 as it is, square bracket to the power of minus 1 as it is. Now I can write this one as 1 minus of. Again, since negative power is there, I will reciprocate it and write it as 1 minus n by minus n. Clear, children? To the power of minus 1. So now here this minus into minus becomes a plus. Clear, children? Okay. So or else what can I do is, look at this. I'll just keep the minus 1 as it is. I'll keep the minus 1 as it is. So minus 1 into plus 1 is minus n, minus 1 plus n to the power of minus 1. You understood? Because here it is a bracket. When you remove the bracket, sign of n will change. Sign of n will be opposite. So now here minus n plus n will get cancelled, and I'll be left with what? Minus 1 by minus n to the power of minus 1. Again, minus minus will get cancelled, 1 by n to the power of minus 1, that is equal to n, because I need to express the power as a positive number. So therefore it becomes a n. Clear, children? So now look at the next question over here. It is 1960 is equal to 2 to the power of a into 5 to the power of b into 7 to the power of c. Calculate the value of. Okay, they have given you some expression. You are supposed to calculate the value of that. So now what I do here is, I will prime factorize 1960. First of all, I'll prime factorize 1960. When I prime factorize 1960, 2, since it is easily divisible by 2 because it's an even number, so 2 9s are 18, 2 8s are 2 zeros are, then 2 4s are 9s are zeros are, again 2 2 2s are, then 2 4s are 2 5s are. Since it is odd number, not possible to divide by 2. So what I do, I'll just directly take it as 5 because it is ending with 5. So I'll take it as 5 over here. So then 5 4s are 20, 5 9s are 49. Okay, so because it becomes 4 over here. 45, 5 9s are 49. Then later 7, 7 7s are, then 7 1s are. So now they have given you that 1960 is equal to 2 to the power of a into 5 to the power of b into 7 to the power of c. So when I prime factorize that one, I have written this one as a 2 to the power of c. How many 2's are there? 1 2 3. So 2 to the power of 3 into 5 to the power of 1, 5 to the power of 1 into 7 to the power of 2, 7 to the power of 2. So when I compare these expressions, so I'll get to know that what is a? A is nothing but a power of 2. So what is the power of 2 over here? It is 3. So I get a is equal to 3. What is b? B is nothing but power of 5. So b is equal to 1. What is c? That is power of 7. So c is equal to 2. Clear? So next what I'm supposed to find out, my job is not at over children. So I have just found out the value of a, b, c. Later I need to find out the value of expression 2 to the power of minus a into 7 to the power of b into 5 to the power of minus c. So when I'm writing 2 to the power of minus a, so 2 to the power of a is what? 3. So 2 to the power of minus 3 into 7 to the power of what is the value of b? It is 1. So into 5 to the power of what is value of c? It is 2. So now I told you that whenever I have negative power, I have to make it as positive power. So 2 to the power of minus 3 can be written as 2 to the power of 3 when it is taken to the denominator. So letter 7 I'll keep as it is, then 5 to the power of 2 as it is. So this becomes 7 into 25 divided by 8. Clear? 25 how? 5 to the power of 2 is 25. So 25 sevens is 175 by 8. So when I express it in the mixed fraction, it is 2 okay, then 1 7 by 8. 21 7 by 8. 16 15 happens 7, okay, then 1 8, then you'll be left with 7. So 21 7 by 8 is the final answer. Now let us take the next example over here. So over here 3 to the power of 2, 8 to the power of 3a is there. So I can write this one as 8 can be written as 2 to the power of 3 to the power of 3a into 2 to the power of 5 into 2 to the power of 2a by here 4 I am writing as it is, then 2 to the power of 11a into 2 to the power of minus 2a. If you want, you can, in this step only, you can write this 4. Okay, in this step only, you can write this 4 as 2 to the power of 2. No issues. Okay, so I can write this 4 as 2 to the power of 2. So later, I can write this one as 2 to the power of 9a by applying the power law into 2 to the power of 5 into 2 to the power of 2a. So divided by 2 to the power of 2 into 2 to the power of 11a into 2 to the power of minus 2a. So apply the product law to the numerator first, then to the denominator. So 2 to the power of 9a plus 5 plus 2a by 2 to the power of 2 plus 11a minus 2a. So I get this one as 2 to the power of 11a minus plus 5 by 2 to the power of 2 minus 2a is there, 11a minus 2a becomes plus 9a. Okay, so now I can apply the quotient law. When I apply the quotient law, this becomes 2 to the power of 11a plus 5 minus 2 minus 9a. Right, so that is equal to 2 to the power of 11a minus 9a is 2a plus of this is nothing but 5 minus 2, that is 3. So this can be written as 2 to the power of 2 to the power of a into 2 to the power of 3. So that is equal to, you can write this one as 8 into 4 to the power of a, or you can keep the final answer here only. Okay, so now 2 to the power of 3 is 8. So 2 to the power of 2 is 4 and a is kept as it is. I hope so this is clear, children. Okay, now let us solve the next one. See here, I am writing this one as 3 into 27 can be written as 3 to the power of 3 to the power of n plus 1 plus of 9 as it is, and here reverse product law, 3 to the power of 3n into 3 to the power of minus 1 by so here I'll write 8 as it is, 3 to the power of 3n also as it is, minus of 5. This 27n can be written as 3 to the power of 3n because 3 to the power of 3 is 27. Clear? So later I can write this one as 3 into 3 to the power of 3n plus of 3 power law. Okay, plus of 9 into 3 to the power of 3n into 3 to the power of minus 1 by 8 into 3 to the power of 3n minus of 5 into 3 to the power of 3n. I don't do anything with the denominator. So in the numerator, 3 into 3 to the power of 3n into 3 to the power of 3, reverse product law. Okay, 3 to the power of 3. So plus of 9 into 3 to the power of 3n into, if you want, you can write this one as 1 by 3 because 3 to the power of minus 1 to the power whole divided by 3 to the power of 3n can be taken common, and 8 minus 5 will be remaining inside the bracket. So if you observe carefully, in the numerator again 3 to the power of 3n is taken common. Here 3 to the power of 3n is taken common in the denominator. In the numerator also 3 to the power of 3n is taken common. Then what you are left with, 3 into 3 to the power of 3, that is 3 to the power of 4. 3 to the power of 4 is 81 plus of this 3 get cancelled, 3 3s will get cancelled, so 3 to the power of n is taken out, so plus 3 I will be left out, divided by 3 to the power of 3n is there, and 8 minus 5 is another 3, so 3 to the power of 3n, 3 to the power of 3n get cancelled, so I'll be left with the 84 divided by 3. So 84 divided by 3 will be nothing but 3 2s are 6, 2 will be left out over here, and 8s are, so 28. So 28 is the final answer. I hope so. Today we learnt the skill of applying the laws of indices. Clear, children? I hope so. Today's class is very useful. So thank you so much. Keep in touch and keep watching the videos for further updates. Thank you so much.